Our history books are missing entire chapters. Long before any written records, cataclysmic floods reshaped continents and erased civilizations, leaving behind only one type of witness. Ancient flood deposits are the silent archives of these forgotten apocalypses, layers of mud and stone that hold Earth's most dramatic secrets. By the end of this journey, you will see human history through an entirely new lens, uncovering the hidden forces that have repeatedly tested our survival. How did a single layer of silt topple a mighty empire? What global disaster was so immense its story was preserved only in mud? The answers are buried in the ground, waiting to challenge everything we think we know about the past. What does it mean for our future if the ground beneath our feet is telling a story we have forgotten how to hear? Those colorful stripes in the Grand Canyon are more than just pretty layers of rock. They are pages in a deep time diary, and some of those pages tell stories of pure chaos. This is the world of ancient flood deposits. Imagine a river, but not the gentle, flowing kind you might picture. This is a wall of water moving with unimaginable force, tearing across the landscape. It picks up everything in its path, from fine dust to massive boulders, and carries it all for miles. When the water finally recedes, it drops all that material in a single, chaotic layer. That layer, left behind like a muddy snapshot of disaster, is an ancient flood deposit. Geologists are the detectives who read these muddy stories. They look for clues that ordinary river sediment just does not have. A river might lay down neat, orderly layers of fine sand over centuries. But a cataclysmic flood does the opposite. It leaves behind a jumble of different materials all at once. You might find a giant boulder, too heavy for any normal current to move, sitting right on top of a layer of the finest silt. The structure of the deposit itself is a mess with patterns that swirl and clash, showing the violent, turbulent energy of the water that placed it there. Sometimes they even find the shells of ocean creatures deposited far inland, a clear sign that the sea itself came rushing onto the land. Each of these layers is a time capsule, sealing a single, terrible moment. While our history books record the rise and fall of empires, these silent archives record the moments the Earth itself rebelled. Understanding how these deposits form, learning to recognize their unique signature, is like finding the key to a locked library. It is the first, crucial step in unlocking the truth about cataclysms so immense that their stories were preserved not in ink, but in stone and mud. These silent layers of mud and stone do not give up their secrets easily. Unlocking their stories requires a scientific toolkit as precise as the events were violent. It begins with stratigraphy, the simple yet profound art of reading rock layers. Think of it as understanding the chapters in a book. The order in which these sediment layers are stacked tells a clear story of sequence: a deep layer of soil, then a sudden, thick band of chaotic debris, and then soil again. This sequence alone reveals a calm period, a sudden catastrophe, and a return to calm. But scientists go much deeper. To pin down exactly when these floods happened, they turn to natural clocks trapped within the sediment. If a piece of wood, a leaf, or even a tiny shell is buried within the flood layer, radiocarbon dating can measure its age with remarkable precision, telling us the exact moment that organic material was sealed away by the deluge. Another technique, called optically stimulated luminescence, does something even more magical. It measures when a grain of sand was last exposed to sunlight. The moment it was buried by the flood, its clock started ticking. By measuring the stored energy within the crystal, scientists can determine how long that grain has been trapped in the dark, giving a direct date for the flood itself. The very texture of the sediment speaks volumes. The size and sorting of the grains act like a speedometer for ancient waters. A layer of uniform, fine sand suggests a powerful but steady and sustained flood, its flow consistent enough to drop particles of a similar size. But a chaotic jumble of boulders, pebbles, and silt all mixed together is the unmistakable signature of a violent, turbulent catastrophe. Water moving with unimaginable force does not sort its load neatly. It just drops everything at once in a messy pile. Then there is the geochemical fingerprint. By analyzing the elemental makeup of the sediments, researchers can trace their origins. A sudden spike in sodium might point to a massive incursion of seawater, a saltwater flood reaching far inland. Distinctive rare earth elements can act like a return address, pointing to the specific mountain range or volcanic region the water tore through. When all these methods are combined, they do more than just date a single event. They allow us to reconstruct entire lost worlds, to see the landscapes and the forces that sculpted them. As these geological clues are pieced together, a startling pattern begins to emerge from the deep past, pointing not to isolated incidents, but to global disruptions that left their mark across continents. 7,600 years ago, a vast freshwater lake lay where the Black Sea rests today. This was not the sea we know, but a placid inland body, home to communities living along its fertile shores. Then the world shifted. Rising global sea levels fed by melting glaciers pushed against a natural earthen dam at the Bosporus Strait. The pressure became too much and the barrier gave way. What happened next was one of the most dramatic geographical transformations in human memory. The waters of the Mediterranean Sea came crashing through in a thunderous cascade, a waterfall with the force of 200 Niagara Falls, roaring non-stop for months, perhaps even years. The inland lake was violently, irrevocably transformed into the saltwater sea of today. The proof of this cataclysm is pulled from the deep, in long cores of sediment drilled from the seafloor. These muddy timelines tell a stark story. At a specific depth, the evidence shifts dramatically. Below that line, you find the shells of freshwater mollusks, the kind that thrived in a calm lake. Directly above, those shells vanish, replaced immediately by the fossils of saltwater species. The sediment layer marking this transition is not a slow accumulation. It is a thick, chaotic deposit of material, the kind laid down in a single, rapid, and violent event. It is the geological signature of a world turned upside down in a very short time. This theory gives a powerful, tangible origin to one of humanity's most enduring stories, the Great Flood. Proponents suggest that the sudden, terrifying inundation, which would have forced entire communities to flee their ancestral homes in a desperate scramble for survival, seared itself into human memory. The traumatic experience of watching their world drown could have been carried by refugees, spreading inland and evolving over generations into the foundational flood myths found in cultures across the region, including the Epic of Noah's Ark. Yet, like any good mystery, this one has its skeptics. Some researchers point to alternative dating of the shells, suggesting the flooding was a more gradual process, a slow creep of saltwater over centuries rather than a single dramatic event. The debate continues, a lively scientific conversation focused on the details within the mud. But whether it was a sudden deluge or a rapid rise, the core evidence remains compelling. The Black Sea was fundamentally and rapidly altered, and the geological record captured that moment of profound change. This single case shows how a layer of sediment can ignite a debate that bridges science and legend, forcing us to reconsider how our deepest cultural stories might be rooted in real, earth-shattering events. The scale of these ancient deluges becomes almost unimaginable when you travel to the deserts of Washington state. Here, a stark landscape known as the channeled Scablands stretches for hundreds of miles. It looks less like a place carved by time and more like a battlefield scarred by a titanic force. This is the work of the Missoula Floods, a series of cataclysms that make even the Black Sea event seem contained. Near the end of the last ice age, a massive glacier acted as a natural dam, holding back an immense lake in what is now western Montana. This ice dam did not just fail once, it fractured and reformed, unleashing the lake's entire contents not one time but repeatedly. Each rupture sent a wall of water, ice, and rock racing across the land at speeds that defy belief, scouring the bedrock down to its bones and carving canyons in a matter of days. The evidence these floods left behind is written on a colossal scale. You can still see gravel bars the size of small hills and ripple marks in the stone that stand 30 feet high. Imagine standing next to a single ripple in the ground that towers over a 3-story building. These are not the gentle ripples from a stream. They are the permanent echoes of currents so powerful they could move house-sized boulders dozens of miles from their source and then simply abandon them in the middle of the plains. The sediment layers here are a chaotic archive of multiple disasters, with each new flood deposit laid brutally on top of the last. When geologist J. Harlan Bretz first proposed this theory in the 1920s, his colleagues were deeply skeptical. The scientific establishment of the time believed in the slow, gradual processes of erosion. The idea that a landscape could be sculpted almost instantly by a biblical-scale flood was considered geological heresy. It took decades of painstaking work, of connecting the dots between the scattered boulders and the towering ripples, for the truth to be accepted. Bretz was ultimately vindicated, his radical theory becoming the foundation for our understanding of megafloods. This story is more than a fascinating piece of geological history. It provides a terrifyingly clear model for how quickly and completely water can reshape a continent. The same kinds of ice-dammed lakes that Bretz studied still exist today in mountainous regions around the world. As our climate changes and glaciers melt, the risk of similar, though smaller, glacial lake outburst floods is a very real modern concern. The Scablands stand as a permanent lesson. They prove that cataclysms of a scale absent from all human chronicles have indeed shaken our world. If such an event could tear through the Pacific Northwest without a single eyewitness to record it for posterity, what other foundational disasters have we simply forgotten? Our planet's memory, locked in stone, suggests we have only just begun to read the first few pages. The fertile plains of Mesopotamia nurtured the world's first cities, but beneath their foundations lies evidence of a far more turbulent past. At the ancient city of archaeologists digging through the accumulated layers of human history made a startling discovery. Between the remnants of one great civilization and the next, they found a clean, thick band of sterile silt, a layer of mud with no artifacts, no signs of life. This was not ordinary river sediment. It was the ghost of a cataclysm, a silent stratum that spoke of a time when the life-giving Tigris and Euphrates rivers turned violently against the people who depended on them. Similar deposits were found at Kish and other Sumerian centers, marking a clear break in the story. These layers of fine clay and sand point to prolonged, devastating inundations that submerged entire regions around 5,000 years ago. What could have caused rivers accustomed to seasonal floods to rise with such destructive, unprecedented force? The answer may lie in a shifting climate or even powerful seismic events that altered the very lay of the land, funneling colossal volumes of water into the heart of civilization. This geological evidence provides a stunningly tangible backdrop to one of humanity's oldest stories. The Sumerian flood myth, later etched into the Epic of Gilgamesh, tells of a great deluge sent by the gods to wipe out humanity. A righteous man is instructed to build a boat to save his family and the seeds of all living things. The parallels to later flood narratives are unmistakable. Radiocarbon dating of organic material trapped within these silt layers places this real-world disaster squarely in the early Bronze Age, a period curiously marked by widespread social collapse, the abandonment of cities, and large-scale migrations. It seems the mud tells two stories simultaneously. One is of environmental crisis, of waters that rose to erase what people had built. The other is a story of profound resilience. After the floods receded, the survivors did not simply vanish. They returned. They rebuilt, often on the very same sites, but with new technologies, new forms of social organization, and a renewed determination. The flood deposit, then, is not just a marker of an ending. It is a dividing line in the archaeological record that signifies a rebirth. This powerful interplay shows us that these ancient layers are more than just geological data. They are the physical evidence that bridges our scientific understanding and our deepest cultural legends. They prompt a haunting question. If the cradle of civilization preserved the memory of a great flood in both its soil and its stories, how many other cultures around the world did the very same thing? Far beneath the surface of the ice in Greenland and Antarctica, another kind of archive preserves the memory of water. These pristine ice cores are time machines, capturing tiny bubbles of ancient atmosphere and layers of dust that fell from the sky each year. When a massive flood occurred, it could throw the global climate system into chaos, and the evidence of that disruption was frozen in place. Scientists analyzed the chemistry of the ice, looking for specific isotopes of hydrogen and oxygen that act as a natural thermometer and rain gauge. A sharp shift in these ratios can mark a sudden, prolonged period of intense wetness on a continental scale. They also find layers of volcanic ash, swept into the atmosphere by eruptions that may have been triggered or accompanied by the same tectonic unrest that caused catastrophic flooding. This data from the poles is then cross-referenced with a quieter record found in lake beds across the world, pollen analysis. Imagine a peaceful lake, its surface dotted with pollen from the surrounding pine forests. Then a great flood drowns the forest, dramatically expanding the shoreline. The very next layer of sediment in the lake core will show a sudden, dramatic shift. The pollen from tall trees vanishes, replaced by a surge in spores from ferns and the pollen of aquatic plants. The landscape itself is speaking through this dusty residue, telling a story of sudden drowning. By weaving together these different threads, the ice chemistry, the volcanic ash, and the silent testimony of pollen, researchers can build what is called a multi-proxy timeline. This approach allows them to see the difference between a local river overflowing its banks and a true global cataclysm. One of the most striking events captured in this way is the 8.2 kiloyear event. Ice cores and lake sediments around the world all record a sudden, dramatic cooling of the climate around 8,200 years ago. The leading theory points to a colossal meltwater pulse from the retreating North American ice sheet, a flood so vast it poured fresh water into the Atlantic Ocean, disrupting the currents that regulate global climate. This was not just one flood in one valley. It was a planetary event whose ripple effects were etched into ice and mud across the globe. This integrated picture reveals a profound truth. These ancient cataclysms were not random, disconnected disasters. They were deeply interconnected symptoms of a dynamic, often volatile planet. A flood in one hemisphere could trigger a drought in another, a lesson written in ice and pollen. Understanding this interconnectedness is the key to grasping the full scale of the challenges our ancestors faced, and how these forgotten crises may have directly shaped the trajectory of human civilization itself. Sometimes the evidence of a lost world surfaces only for a moment at the lowest of tides. Along certain coastlines from Wales to the North Sea, the receding ocean unveils a ghostly landscape. The stumps of ancient forests stand silent in the mud, their roots still anchored in a soil that was once dry land. These submerged woodlands and the vast, waterlogged peat bogs that often accompany them are among the most poignant flood indicators. They are not layers of chaotic debris, but the preserved remnants of a living world abruptly drowned. Each tree stump holds a chronology in its rings, a record of the years when sunlight fell on its leaves before the waters rose for the last time. Peat bogs, which form over centuries from compressed organic matter, often yield even more direct connections to the past. Archaeologists have recovered tools, ceremonial items, and even the preserved footprints of people who walked these surfaces when they were solid ground. The story of their end is written in the sediment, a deep, stable layer of dark peat filled with the pollen of terrestrial plants and the remains of freshwater insects is suddenly capped by a thick, gray layer of marine clay. This stark transition marks the moment the sea broke through, not with a slow creep, but in a rapid, devastating incursion that buried the land and everything on it. Perhaps the most famous of these lost landscapes is Doggerland. This vast, inhabited plain once connected Britain to mainland Europe, a fertile territory roamed by animals and hunter-gatherer communities. Then, around 6,500 years before the Common Era, it was swallowed. Sediment cores taken from the floor of the North Sea tell a chilling tale. The final layers of peat, representing the last of the marshes and forests, are torn and mixed with sand. This is the geological signature of a powerful, catastrophic event, likely a tsunami triggered by an underwater landslide off the coast of Norway. The water did not just rise, it surged violently and irrevocably, claiming the land. These environments are more than just geological curiosities. They are natural archives of human displacement, capturing the precise moments when entire territories vanished beneath the waves and coastal societies lost their homelands. The vulnerability they reveal is not a relic of the deep past. It is a powerful lesson about the enduring relationship between human communities and the sea, a theme that becomes even more stark when we turn to the geological fingerprints of tsunamis. The ocean itself can reach deep inland, leaving a calling card no river flood ever could. A tsunami does not just bring water, it brings the seafloor with it, depositing a chaotic, undeniable signature on the land. These are not layers of fine silt from an overflowing river. A true tsunami deposit is a sheet of coarse sand and gravel, often filled with the shattered shells of marine creatures and other deep-water debris, pushed miles inland and dropped atop the quiet, finer soils of the coastal plain. The structure of the layer itself tells the story of the wave's power and retreat. It typically thins as you move away from the coast, a clear trail of the wave's fading energy. And within that sand, scientists find microscopic fossils called diatoms, tiny organisms that live in specific ocean depths. Finding deep-water diatoms far inland is like finding a fish tank from the abyss in the middle of a forest, conclusive proof that the water came from the open sea. The Sendai Plain in Japan is a living archive of these events. Sediment cores here reveal multiple sand sheets, each one a ghost of a past tsunami, separated by layers of quiet soil. By dating these layers, researchers have uncovered a terrifying pattern, a recurrence interval showing that cataclysmic waves have struck this coast for thousands of years. This long-term geological memory is now fundamental to modern hazard planning, helping to define evacuation zones and build coastal defenses based on the full, frightening history, not just the short span of human records. The trigger for these ocean-borne cataclysms can be a massive earthquake or a colossal underwater landslide. One of the most significant events identified in the geological record is linked to the Storegga slide. Around 8,100 years before the Common Era, a vast section of the continental shelf off the coast of Norway catastrophically collapsed, sending an immense volume of sediment sliding into the deep ocean. The displacement of water generated a tsunami of staggering proportions. Its deposits have been identified along coastlines from Scotland to Greenland, and it is widely considered the most likely cause for the final, rapid drowning of the Doggerland landmass. By reading these sandy signatures, scientists can reconstruct not just the fact of a tsunami, but its magnitude and its source, turning a single layer of sediment into a detailed report on a prehistoric disaster. This evidence forces a humbling realization. Our coastlines are not permanent. They are dynamic frontiers that have been brutally reshaped by waves that rise from the deep with little warning. And if the ocean can reach so far inland, what other hidden vulnerabilities lie waiting within the continents themselves, far from any shore? These quiet lakebeds hold calendars of catastrophe. In the deep, still waters of ancient lakes, a different kind of flood record is kept, one with the precision of a master clockmaker. Instead of chaotic jumbles, these archives are built from delicate, paper-thin layers called varves. Each pair of light and dark bands represents a single year. The pale layer is summer silt, fine particles settled from calm, sunlit waters. The dark layer is winter clay, the remains of organic material that drifted down during the cold, still months. This rhythm creates a continuous timeline stretching back tens of thousands of years, a natural chronology more detailed than any human record. But sometimes this gentle rhythm is violently broken. A single, unusually thick layer of coarse sand and gravel suddenly appears within the fine, orderly laminations. This is the lake's memory of a great flood. A torrential rain or a sudden glacial melt would have churned up the lake's shores and river inlets, carrying a heavy load of sediment and dumping it all at once into the deep, quiet basin. That single, coarse layer is a time-stamp of disaster, marking the exact year the weather turned catastrophic. By extracting long cores of sediment from lakes like Suaijtsu in Japan or Lake Van in Turkey, scientists can read these timelines with astonishing clarity. They can identify not just one flood, but a pattern of them. For instance, varve records from Scandinavian lakes show clusters of severe flooding occurring during periods known as solar minimums, when the sun's activity noticeably decreased. This suggests a profound and unexpected link, a celestial influence on our planet's rainfall and flood cycles. The lake mud tells us that the forces driving these cataclysms may not be entirely of this earth. This meticulous dating does more than just list ancient disasters. It allows researchers to correlate a specific flood year in a Turkish lake with a period of famine noted in tree rings from Ireland, or with a climatic anomaly like the Little Ice Age. These connections reveal a world where environmental upheaval was often synchronized across vast distances, a global network of crises. Such a perspective fundamentally challenges the linear, progressive narratives of history we often tell. Instead of a steady march forward, these varved records suggest a story of fits and starts, of civilizations advancing only to be tested by recurring, cyclical disasters. As we refine our ability to read these natural calendars, we are forced to ask not just what happened, but why it keeps happening. And this leads to an even deeper question: how did these recurring cataclysms shape the very fabric of the societies that endured them? 4,200 years ago, the world grew desperately dry. From the pyramids of Egypt to the great cities of the Indus Valley, a climatic crisis unfolded, one we now call the 4.2 kiloyear event. For decades, the story seemed straightforward, a mega-drought that starved empires of water and led to their collapse. But the flood deposits from this period reveal a far more complex and terrifying reality. It was not simply an age of drought, it was an age of chaos. In the Nile Delta, the sediment layers tell a story of violent swings. A thick band of silt from a powerful, destructive flood lies right next to a layer cracked with desiccation, filled with white, crystalline minerals like gypsum. These are evaporites, minerals that form when standing water evaporates completely, leaving only a chemical crust. This alternating pattern reveals a climate gone haywire, where erratic monsoons caused the river to swing between two extremes, catastrophic overflow and utter dryness. The very water that gave life could arrive with the force of a hammer, only to vanish for years, leaving the land to bake and crack. This climatic instability placed an unbearable strain on the world's first great agricultural societies. The Akkadian Empire in Mesopotamia, a powerhouse of its time, crumbled. Inscriptions speak of salinized fields and famine. The Old Kingdom of Egypt, the age of the pyramid builders, dissolved into a period of fragmentation and hardship. The geological evidence suggests these were not isolated failures, but connected symptoms of a global phenomenon. By correlating the flood and drought layers in the Nile with data from ice cores and speleothems, the cave formations that grow in drips and act as ancient rain gauges, a stark picture emerges. The 4.2 kiloyear event was a planetary megadrought punctuated by episodes of catastrophic flooding. It was a paradox of too much and too little water all at once. This complexity forces us to rethink the nature of cataclysm. These were not single, monolithic disasters. They were a cascade of interconnected environmental stresses, a push and pull of opposing forces that could reshape human destiny. As we will see, this pattern of climatic whiplash was not confined to the Old World. The very same forces were at work, writing a similar story of upheaval in the ancient Americas. High in the Andes, the deep blue waters of Lake Titicaca hold a secret history of cataclysm. Sediment cores pulled from its bottom reveal a story far more turbulent than the serene surface suggests. Interwoven with the fine, annual layers of mud are startling bands of coarse gravel and tangled terrestrial plants, deposits that speak of sudden, violent inundations. These layers are the geological ghosts of ancient disasters, likely triggered by massive landslides in the surrounding mountains or the catastrophic failure of ice-dammed glacial lakes high in the peaks. The timing of these flood deposits is what makes them so compelling to archaeologists. They coincide strikingly with a period around 1,100 years ago when the Tiwanaku state, a sophisticated civilization that had thrived for centuries, entered a phase of profound decline and eventual dispersal. Imagine the carefully engineered raised field systems and complex water channels that sustained Tiwanaku agriculture. A single cataclysmic flood, dumping tons of rocky debris across these fertile terraces, would not just damage the season's crops, it could obliterate the very infrastructure that made life possible in this high-altitude environment. The evidence in the mud is further clarified by the chemistry of ancient snail shells preserved within the sediment. Isotopic analysis of these shells points to dramatic and rapid swings in the lake's water level. This suggests the Tiwanaku people were not battling a single enemy, but a cruel climatic paradox, a perfect storm of punishing droughts punctuated by catastrophic floods. Researchers attribute this instability to intense phases of the El Niño Southern Oscillation, a climate phenomenon that can flip the region from extreme wet to extreme dry with devastating speed. The societal fabric, woven over generations, was likely torn apart by this environmental whiplash. This Andean case is a powerful reminder that cataclysms were a global reality. The flood deposits here do not just record a geological event, they fill a critical gap in the human story, explaining the vulnerability of even the most resilient societies to forces beyond their control. As we shift our gaze from the high mountains to the world's largest rainforest, the evidence for planet-shaping deluges takes on an entirely different, yet equally dramatic form. Deep within the Amazon, a forest floor of startling richness tells a paradoxical story. Scattered across the basin are patches of remarkably fertile soil known as terra preta, or Amazonian dark earths. This is not ordinary jungle soil, but a human-made landscape, a testament to ancient societies who enriched the earth with charcoal, broken pottery, and organic waste over generations. Yet woven between these layers of human innovation is another, more forceful signature. Sediment cores reveal that these dark earths are interleaved with thick layers of silt and clay, deposits from the Amazon River's ancient and dramatic floods. The river did not just flow, it periodically broke its banks in colossal events known as avulsions, radically shifting its course and dumping mineral-rich sediments carried all the way from the Andes Mountains. For the people living here, these floods presented a profound duality. A moderate deposition of fresh silt could be a gift, a natural fertilization that replenished the soil and enabled agricultural booms, supporting the complex societies that once thrived here. But a core also reveals something else, layers of heavy, sterile clay. These represent floods of a different magnitude, catastrophic inundations that would have buried entire landscapes under a thick, waterlogged seal, smothering crops and making the land unworkable for years. The timing of some of these major clay layers coincides with periods of climatic stress, such as the medieval climate anomaly around 1,000 years ago, suggesting that these cataclysms may have triggered large-scale movements of people, dispersing communities and reshaping the human map of the Amazon. So, was the flood a destroyer or a life-giver? The soil itself provides no simple answer. It presents a cycle of creation and destruction, where the very force that could erase a village was also the same force that laid the foundation for its successors' prosperity. This deep-seated ambiguity, written in the earth, forces us to ask how a culture remembers such a dual-natured power. The answer may not lie in the soil alone, but in the stories passed down through countless generations. The stories passed down through generations are not just myths, they are memories. For thousands of years, indigenous cultures around the world have preserved accounts of great floods, narratives that now find a startling echo in the layers of mud and stone. Aboriginal communities in Australia tell of a time when the sea rose, drowning familiar coastal plains and river valleys. This oral history aligns perfectly with the geological evidence found in places like Sydney, where sediment cores reveal ancient, submerged landscapes that were once dry land. The story and the science are telling the same story of loss and transformation. On the other side of the Pacific, numerous Native American tribes have legends of immense deluges, with descriptions of water moving with such force that it sculpted the land itself. These accounts read like eyewitness reports of the Missoula Floods, describing a cataclysm so immense it carved the channeled Scablands. When a tribal elder recounts a story of the water covering the world, they are providing a data point that geology can now corroborate. By treating these oral traditions not as fables but as complementary records, researchers gain a more nuanced understanding of these events. They are not just dating a layer of silt, they are beginning to grasp the human impact, the trauma of displacement, and the resilience required to rebuild a world. This interdisciplinary approach does more than validate a scientific finding. It validates cultural heritage, honoring the ways in which communities have processed and preserved earth-shattering events across millennia. It reminds us that history is not only found in what is written, but in what is lived, felt, and recounted around countless fires. This powerful convergence of story and soil bridges the deepest of divides, connecting empirical data with the enduring human spirit. With this unified perspective in mind, we can now employ modern tools to bring these forgotten cataclysms back to life in breathtaking detail. A laser pulse fired from an aircraft can see what our eyes cannot. This is the power of LiDAR, a technology that strips away the dense veil of forests and soil to reveal the ghostly contours of ancient landscapes. By mapping the ground surface with incredible precision, LiDAR unveils the subtle, sweeping shapes of forgotten river channels and vast sediment fans, features completely invisible to a person standing on the ground. These are the footprints of cataclysms preserved for millennia under the jungle canopy. In the Maya lowlands of Central America, this technology has revealed something astonishing. Scattered across the digital terrain are the geometric patterns of ancient canals and raised fields, evidence of sophisticated agricultural systems. But cutting through these human creations are thick, wide bands of clay, the deposits of colossal floods that clearly swept across the land. The LiDAR data allows researchers to do more than just see these features. It allows them to measure. They can calculate the sheer volume of sediment dumped by a single event and map the full, terrifying extent of the inundation, whether it was driven by a hurricane storm surge or a river violently abandoning its course. To peer beneath the surface, scientists combine this laser mapping with ground-penetrating radar. This tandem approach builds a three-dimensional model of the underground stratigraphy, revealing the layer cake of flood deposits stacked one on top of the other. Seeing this vertical sequence is the key to understanding that these were not one-off disasters, but part of a recurring cycle of cataclysms that the Maya people had to endure and adapt to, again and again. This non-invasive eye in the sky is accelerating discovery at an unprecedented rate, forcing us to reassess landscapes we once believed were stable and peaceful. The ability to see through the Earth itself is opening entirely new frontiers in our understanding of ancient floods. It prompts a profound question: how many more of these lost cataclysms are waiting, hidden just beneath our feet, for the right technology to reveal their story? A thin, dark layer of sediment stretches across continents, a silent line in the soil that marks one of the most contentious debates in modern science. This is the black mat, a stratum of carbon-rich material found from North America to Europe, dated to around 12,800 years ago. For proponents of the Younger Dryas impact hypothesis, this is not just another layer of mud, it is the fallout from a cosmic catastrophe. They argue that this black mat contains the chemical fingerprints of an extraterrestrial impact, including microscopic nanodiamonds formed under immense pressure and a spike in the rare element iridium, a telltale sign of a comet or asteroid. This layer, they suggest, caps a landscape scarred by unimaginable floods, the direct result of a comet fragment striking the North American ice sheet and triggering a sudden, brutal freeze known as the Younger Dryas period. The evidence they cite is both varied and dramatic. Ice cores from Greenland show sharp increases in ammonium and nitrate at this exact time, chemicals consistent with continent-spanning wildfires that would have raged in the impact's aftermath. And then there are the Carolina Bays, hundreds of thousands of enigmatic, elliptical depressions scattered across the eastern United States. To some researchers, their precise orientation and composition suggest they are the scars of secondary impacts created by chunks of the disintegrating comet that slammed into the Earth. their basins later filled with washover deposits from the resulting floods and meltwater. The sheer scale of flooding implied by this theory is almost beyond comprehension, a deluge of meltwater that would have wiped out entire ecosystems and the megafauna that depended on them, while also presenting a formidable barrier to the early human populations who were just beginning to explore the continents. Yet, this hypothesis is far from settled science. Many geologists and climatologists offer a different, purely terrestrial explanation. They argue that the black mat is the result of widespread peat fires in a drying landscape, and that the nanodiamonds and iridium could have other, more mundane origins. The Carolina bays, they suggest, are more likely the work of wind and water acting over millennia in a thawing landscape. The debate is a fiery one, a classic scientific clash between a revolutionary idea and established gradualist models. But regardless of which side is ultimately proven correct, the Younger Dryas debate illustrates a profound shift in how we view these ancient cataclysms. It forces us to lift our gaze from the Earth itself and consider the possibility that the trigger for some of our planet's most dramatic floods came from the cold vacuum of space. These layers of sediment are no longer just records of water and ice. They are potential archives of a day when the sky fell. This ongoing conversation demonstrates how a single, enigmatic flood deposit can sit at the very center of a scientific revolution, challenging our most fundamental assumptions about the forces that have shaped human destiny. The end of the last ice age was not a gentle thaw, but a series of violent ruptures. Deep beneath the ocean, along the edges of submerged continents, lie the records of these events. Geologists call them meltwater pulses, sudden and colossal releases of water from the collapsing ice sheets that once blanketed the continents. One of the most dramatic, known as Meltwater Pulse 1A, occurred around 14,600 years ago. It is a staggering event to consider, a global deluge that raised ocean levels by an estimated 20 meters in just a few centuries. That is a rate of sea level rise dozens of times faster than what we observe today. The evidence for this cataclysm is written in the coastal flood deposits it left behind. Along the coast of Florida and in the shallow seas around Australia, scientists find vast plains of submerged peat. These are the drowned remains of ancient wetlands and forests that once grew on dry land far from the ocean's edge. The sequence is always the same, a deep layer of dark, organic peat, filled with the roots of terrestrial plants and the bones of land animals, abruptly sealed by a thick, clean layer of marine sand. This sand is the calling card of the invading sea. The moment the waves finally washed over these landscapes and buried them for good, each of these submerged peat beds marks a coastline that vanished, a frontier that retreated not by inches per year, but by kilometers in a single human lifetime. To date these catastrophic inundations, scientists turn to two powerful natural calendars. Corals are meticulous timekeepers, and ancient reefs that are now found deep underwater were once living in the sunlit shallows. By dating their death, we can pinpoint the moment the rising sea drowned them. Similarly, speleothems, the majestic formations found in caves, can only grow when they are above the water table. A stalagmite that stops growing at a specific date signals the moment its cave was flooded by rising seas. Together, these records confirm that the meltwater pulses were not slow and steady, but episodic and violent, like a series of great leaps rather than a smooth climb. For the human populations living along those ancient shores, this would have been a time of relentless retreat. The land they hunted and foraged on would have been shrinking before their eyes, generations of knowledge about sacred places and resource grounds rendered obsolete by the encroaching saltwater. This geological precedent carries a sobering message for our modern world. It demonstrates that our planet's climate system is capable of nonlinear responses, of reaching a tipping point and then changing with breathtaking speed. The ice stored in Greenland and Antarctica today represents a similar, vast reservoir of potential sea level rise. Understanding these ancient pulses is not just an academic exercise, it is a crucial key to projecting our own future, a stark reminder that the ground we think is solid can, and has, disappeared beneath the waves. The ingenuity of our ancestors is written not only in their monuments, but in the very dirt beneath their cities, in the meticulously planned streets of Mohenjo-Daro in the Indus Valley. Archaeologists have uncovered one of the world's earliest and most sophisticated urban drainage systems. The entire city was built upon massive, man-made platforms of earth and mud brick, raising it above the floodplain. A network of covered channels lined with baked brick ran beneath the streets, designed to carry away wastewater and seasonal rains. This was a civilization that expected water and engineered a graceful coexistence with its annual rhythms, yet the sediment layers tell a more complex story. Between the orderly bricks of the city walls, you find strata of fine, laminated silt. These are the quiet ghosts of floods that overtop the defenses, seeping into neighborhoods and leaving a thin film of mud in their wake. In some areas, thicker deposits of coarse sand clog the ancient drains, evidence of instances where the water's force was simply too great, overwhelming the infrastructure and forcing a laborious cleanup. The people of Mohenjo-Daro did not just build against the flood, they learned to live with its residue, repeatedly clearing their channels and rebuilding, their resilience etched into the stratified cycles of construction and repair. Half a world away, along the volatile Yellow River, another civilization waged a perpetual battle with water. Ancient Chinese societies began constructing earthen dikes to contain the river's flow nearly 3,000 years ago. Their entire agricultural system depended on this delicate balance, coaxing water into canals for irrigation while holding back its destructive power. Sediment cores drilled from the North China Plain reveal the dramatic cost of this struggle. Deep within the earth, you find a thick, stable layer of fine, fertile lower soil, representing centuries of stable farming. Then, abruptly, a starkly different layer appears, a chaotic band of coarse sand and gravel that cuts through the ancient farmland like a scar. This is the geological signature of a dike breach, a cataclysmic event when the river, swollen with sediment, tore through its artificial confines. The historical records of China's dynasties often link such catastrophic floods with periods of profound social unrest and the fall of ruling houses. The river's fury was not just an environmental event, it was a political force. Each breach deposited a new layer of sediment, reshaping the landscape and the human relationship with it, often prompting a complete rethinking of water management strategies and the very structure of the state. These ancient adaptation strategies, encoded in both archaeology and geology, speak to a timeless dialogue between human ingenuity and natural force. The raised platforms of the Indus and the towering dikes of the Yellow River were monumental achievements, testaments to a deep understanding of the local environment. Yet the flood deposits that infiltrated their cities and buried their fields serve as a humbling counterpoint. They mark the moments when nature's power exceeded the limits of even the most advanced technology of the age. This historical wisdom is far from a relic. It directly informs modern civil engineering and disaster preparedness, teaching us about the long-term sustainability of water management and the critical importance of designing for failure. The layers of silt and sand are a permanent archive of past vulnerabilities, reminding us that our own sophisticated systems exist within the same ancient cycle of creation and destruction. The ground holds a deep memory of how societies have weathered these repeated tests, offering not just a warning, but a guide for navigating an uncertain future. This vast green Sahara seems almost impossible today, yet the sediment record is unequivocal. Beneath the sands of the world's largest desert lie the ancient shorelines of megalakes, the most stunning of which was Megalake Chad. This colossal body of fresh water once sprawled across an area larger than the Caspian Sea, a shimmering blue expanse in the heart of a verdant savanna. The proof is not in grand ruins, but in the microscopic world. Sediment cores extracted from the now dry lakebed are packed with the delicate glass skeletons of diatoms, tiny algae that thrived in those clear, deep waters. Mixed in are the fossilized bones of Nile perch, a fish that requires a vast, interconnected aquatic system to survive. These fragile remains are time-stamped to a period around 6,000 years before the Common Era, a time of remarkable humidity when the Sahara was a mosaic of grasslands and lakes. Then the record turns stark. The dark, organic mud rich with life is abruptly capped by a blindingly white layer. This is a crust of evaporites, minerals like gypsum and halite that crystallize when a body of water vanishes completely under a scorching sun. Directly on top of that lies the signature of the desert we know today, a layer of fine, cross-bedded dune sand. This dramatic transition in the core tells a story of collapse, not a slow change over millennia, but a rapid, climatic tipping point that transformed a paradise into a desert in a geological instant. Researchers point to a phenomenon known as orbital forcing, a slow wobble in Earth's tilt that gradually reduced the intensity of the African monsoon. The life-giving rains failed season after season. The consequences for the human populations were catastrophic. In their final days, these giant lakes, starved of replenishment, would have experienced wild and unpredictable swings. A single, intense rain event on a shrunken but still immense lake could have caused a sudden, devastating overflow, a final catastrophic flood scouring the landscape before the eternal drought took hold. Communities that had thrived for generations beside these waters were faced with an impossible choice: stay and face a certain end, or abandon their ancestral homes in a desperate, continent-altering diaspora. The silent layers of sediment in the Sahara serve as a sobering planetary warning. They demonstrate with chilling clarity that a climate system can remain stable for ages, supporting vast civilizations, and then flip into a new, hostile state with shocking speed. This evidence from the desert perfectly complements the flood records from Mesopotamia and the Americas, revealing that these cataclysms were not isolated tragedies, but interconnected symptoms of a volatile global climate, a pattern of upheaval that has shaped the human story from its very beginning. A volcano's fury is not confined to fire and ash. When a peak like Thera explodes, it can unleash a different kind of killer, one made of water and mud. The Minoan eruption 3,600 years ago did exactly that, sending colossal tsunamis across the eastern Mediterranean and triggering torrents of volcanic slurry known as lahars. These are not simple mudslides. A lahar is a concrete-like river of ash, rock, and melted snow, capable of scouring valleys down to bedrock and burying entire landscapes under a hardening gray tomb. The sediment signature of a lahar is unmistakable. Unlike a river's sorted layers, a lahar deposit is a chaotic, unsorted jumble. You might find chunks of pumice the size of fists mixed with fine volcanic ash and the shattered shells of marine creatures, all cemented together. This mixing of volcanic and marine material is the smoking gun, proving that the eruption interacted violently with the sea. On the island of Crete, cores have revealed these very layers far inland, a silent witness to the floods that likely crippled Minoan ports and farmland, contributing to the civilization's sudden decline. The reach of these events is staggering, with identifiable thorough ash found in sediment layers hundreds of kilometers away, creating a precise timeline of the catastrophe. This ancient threat is not locked in the past. In the modern era, Mount Rainier in Washington state is considered one of the most dangerous volcanoes on Earth, not because of its potential for a massive explosion, but because of its immense glaciers. A small eruption or even a large earthquake could rapidly melt that ice, generating lahars that would race down populated valleys at highway speeds. Geological maps of the area are layered with the deposits of past lahars, some of which traveled all the way to what is now the Puget Sound. These ancient mudflows provide the baseline data that modern emergency planners use to create evacuation routes and warning systems. By dissecting these stratified records, volcanologists can reconstruct not just the size of an eruption, but its cascading consequences, offering a vital analog for future disasters. This deadly synergy between earth and water reveals a fundamental truth that our planet's most destructive forces are often deeply intertwined. The ground that shakes with tectonic strain can be the very same force that summons the flood. Sometimes the ground itself turns to water. During a powerful earthquake, the violent shaking can radically transform stable, waterlogged soil into a temporary liquid. This phenomenon, called liquefaction, occurs when the pressure from the seismic waves forces the water between soil particles to the surface. The ground, once solid, instantly loses its strength. It can no longer support the weight of what is above it. The soil flows, fracturing and warping the landscape. On the surface, this liquefaction often manifests as sand blows, where water and fine sand erupt from fissures like small volcanoes, spreading a distinct layer of silt across the land. If this occurs near a river, the sudden ground failure can collapse banks, block channels, and trigger widespread flooding, leaving behind a unique sediment signature that geologists can read centuries later. A dramatic example of this lies in the American Midwest, far from the tectonic boundaries we typically associate with earthquakes. The New Madrid seismic zone was the source of a series of massive quakes between 1811 and 1812. The shaking was so intense it was said to ring church bells in Boston. Paleoseismologists, scientists who study prehistoric earthquakes, have excavated the region and found abundant evidence of liquefaction from those events. But they have dug deeper, uncovering older, similar layers of erupted sand and silt. These stratified deposits reveal a startling pattern. Massive, New Madrid-level earthquakes have struck this same region not just once, but repeatedly over thousands of years. The evidence is often found in the form of sand dikes, vertical intrusions where liquefied sand was forcibly injected upward into overlying clay and soil. This tells researchers that the shaking was not just strong, it was violent enough to fundamentally reshape the hydrology of the entire area. Historical accounts from the 1811 quakes describe the ground rolling in visible waves, the Mississippi River momentarily flowing backwards, and vast areas of land sinking to form temporary, swampy lakes. The geological record confirms these stories, with flood deposits appearing precisely where the land subsided. This powerful interplay between shaking earth and flowing water is not confined to river valleys. In a place like the Dead Sea, sediment cores tell a parallel story from a completely different environment. Here, researchers examine the lake's finely laminated layers of salt and mud. Within this orderly sequence, they find sudden, thick, chaotic bands of sediment known as turbidites. These are the remains of underwater landslides, triggered when an earthquake shook the surrounding cliffs, sending massive amounts of material sliding into the deep basin. The displacement of water by these landslides would have generated large, tsunami-like waves that crashed against the shores, scouring the coastline and leaving their own distinct layer of debris in the cores. By carefully dating these turbidite layers and correlating them with the historical earthquake record of the Middle East, scientists can precisely determine the timing and intensity of ancient seismic events. This geological detective work is far from an academic exercise. Each liquefaction feature and each turbidite layer is a data point that dramatically improves our modern seismic hazard maps. Understanding that a region like New Madrid has a long, violent history of cataclysmic quakes forces a reassessment of building codes and disaster preparedness for millions of people. These silent layers of sand and silt remind us that the solid ground we build our lives upon is part of a dynamic and at times violently unstable planetary system. This deep instability raises a profound question. If the very Earth can turn to liquid and rivers can be rerouted in a single day, what other hidden forces lie in wait, capable of rewriting our world without warning? Our planet breathes in a slow, rhythmic cycle that orchestrates the very pulse of water across continents. These vast climate oscillations, like the El Niño Southern Oscillation and the North Atlantic Oscillation, are the master conductors of flood and drought, and their ancient performances are recorded in the mud. In the high Andes of Ecuador, the lake known as Laguna Palcacocha holds a particularly sensitive diary. Its finely layered varves, those annual couplets of light and dark sediment, are punctuated by strikingly thick bands of coarse material. Each of these coarse layers corresponds to a powerful El Niño event, a time when warm waters pool in the Pacific, triggering torrential rains that scour the mountainsides and dump their rocky load into the lake's quiet depths. The sediment acts as a direct recording of the storm's intensity, a proxy for chaos preserved with stunning clarity. On the other side of the world, the same story is written in a different medium. The peat bogs of Europe, those spongy archives of organic matter, also capture the legacy of these atmospheric rhythms. Cores extracted from these bogs show distinct mineral layers, sand and silt washed in from overflowing rivers during intensely wet periods. Researchers have correlated these flood layers with positive phases of the North Atlantic Oscillation, a climate pattern that, during the medieval warm period, steered relentless storms into Europe. These were not merely seasons of bad weather, they were systemic shifts that swelled rivers for years, testing the resilience of societies whose stability was deeply tied to the land. These oscillations create a pendulum swing between wet and dry epochs, and the flood deposits mark the extreme, water-laden apex of the swing. For farming communities, these were cataclysmic interruptions. A single devastating flood could erase a year's harvest, but a cluster of them, driven by a decades-long wet phase, could lead to widespread famine, economic collapse, and forced migration. The geological record suggests that these cycles of abundance and hardship are a fundamental part of Earth's long-term climate personality. This deep time perspective is not just about understanding the past, it is a key to navigating the future. In a warming world, the potential energy available to these climate modes increases, raising the probability of more frequent and intense extreme weather. By learning the rhythm of these ancient floods, we gain a critical context for the changes we are observing today. The ground tells us that cataclysms are rarely random, but are often the most dramatic notes in a much larger planetary symphony. But the Maya collapse was more than just a slow death by thirst. Sediment cores pulled from the tranquil lakes of the Yucatan Peninsula reveal a startling twist in this ancient story. Alongside the expected evidence of drought, researchers found thick, pale layers of gypsum and dense clay. These are not the marks of a dry sky. They are the ghostly footprints of immense, catastrophic rainfall. During the Terminal Classic period, around the 9th century, it seems the climate did not just abandon the Maya to a relentless sun. It lashed them with violent storms, possibly from powerful hurricanes or a dramatically shifted monsoon belt. Imagine the very infrastructure designed for survival turning against them. Their intricate canal systems and carefully managed reservoirs, built to hoard every precious drop during dry seasons, would have been overwhelmed. These sudden deluges would have scoured the thin, fertile topsoil from their agricultural terraces, choked their waterways with sediment, and contaminated their stored freshwater reserves. The societal stress became unbearable. A kingdom could be struggling through a decade of drought, its people united by the shared challenge of scarcity, only to have a single cataclysmic flood wipe out the remaining food stores and poison the water supply. This climate whiplash, a cruel oscillation between searing aridity and devastating inundation, is captured perfectly when scientists compare the lake's sediments with speleothems from nearby caves. The cave formations act as ancient rain gauges, their chemistry recording periods of both extreme dryness and exceptional wetness. The timelines match, revealing a world of profound instability. It was not one enemy that confronted the Maya, but a perfect storm of environmental chaos. The resulting pressure, layered atop existing conflicts and resource wars, likely made centralized power and urban life unsustainable. This nuanced view, painted in layers of gypsum and clay, forces us to reconsider the nature of civilization's end. It was not a simple, single-cause failure, but a complex unraveling driven by a volatile and unpredictable planet. The ground tells us that sometimes collapse arrives not with a whimper, but with a drought broken by a cataclysm. The seafloor off Norway gave way in a single, catastrophic collapse. Around 8,100 years before the Common Era, a massive section of the continental shelf known as the Storegga Slide detached, sending an unimaginable volume of sediment plunging into the deep ocean. The displacement of water generated a tsunami of staggering proportions, a wave that raced across the Atlantic. Its evidence is written in the quiet soil of coastal peat bogs from Scotland to Greenland. In these tranquil, low-lying areas, scientists find a single, stark layer of coarse sand and marine shells abruptly interrupting the dark, organic accumulation of ancient marshland. This sand sheet, often only a few centimeters thick, is the wave's permanent signature. It contains microscopic fossils of deep water diatoms, organisms that have no business being so far inland, proving the water that carried them came from the open ocean. Radiocarbon dating of plant material directly beneath this sand layer consistently points to the same moment in time, confirming a transoceanic cataclysm. For the Mesolithic communities living on the low-lying plains of Doggerland, this wave would have been an apocalyptic sight. The gently sloping terrain offered no protection, the water surging far inland with relentless force. Settlements were swept away, hunting grounds submerged, and the very geography of their world was permanently altered. This event likely delivered the final blow to a land already slowly drowning from rising sea levels, forcing the survivors into a desperate migration that reshaped the human map of prehistoric Europe. Today, the study of these sand layers is more than an archaeological pursuit. By analyzing their thickness and inland extent, scientists can model the tsunami's height, speed, and power. This deep time data is crucial for assessing the risks to modern offshore infrastructure, from oil platforms to subsea internet cables, reminding us that the seabed is not always a stable foundation. The Storegga Slide stands as a humbling lesson written in coastal mud, a testament to the ocean's capacity to reach across vast distances and rewrite human history in a single, violent surge. A story told in Babylon echoes one from India and another from Greece. the Great Flood appears in the myths of hundreds of cultures, separated by oceans and millennia, yet their core remains hauntingly the same. A divine warning, a boat built for survival, a world washed clean, and a handful of people chosen to begin again. This is more than a coincidence of imagination. It is the resonance of cultural memory. When researchers place these ancient stories side by side with the geological record, the parallels become undeniable. The Mesopotamian Epic of Gilgamesh describes a flood so vast it terrified even the gods, a cataclysm that aligns with the thick silt layers found at the ruins of Ur. The Hindu scriptures tell of Manu, who was told to build a massive ship to save himself from a rising sea, a narrative that finds its echo in the submerged peat beds and coastal flood deposits of the Indian subcontinent. These shared story elements act as a cultural fingerprint, pointing back to a shared experience of a real, terrifying event. The Greek legend of Deucalion and Pyrrha, who survived a great deluge to repopulate the earth, may well be a folk memory of the tsunamis that radiated from the thorough eruption, scouring the coasts of the Mediterranean. In China, the foundational legend of Great Yu controlling the floods, not by stopping them but by channeling their power, directly mirrors the historical and sedimentary evidence of the Yellow River's constant, catastrophic avulsions. These myths were not mere fables, they were the vital technology of their time, a way to process profound trauma and encode critical survival knowledge. The recurring motif of a righteous survivor building a vessel served as a metaphorical blueprint for resilience, teaching each new generation that preparedness and moral fortitude were the keys to weathering the storm. By weaving together the hard data of sediment cores with the soft power of story, we achieve a far richer understanding. We see that our ancestors were not just recording a disaster, they were making meaning from it. They transformed the terror of a collapsing world into a narrative of hope and renewal, ensuring that the lesson of the flood would never be forgotten. This fusion of science and the humanities reveals the deep psychological impact of these cataclysms, showing us that the most enduring legacy of a forgotten apocalypse is not just the layer of mud it left behind, but the story we told about it around the fire. The trauma of a cataclysm echoes far beyond the physical destruction. These ancient floods did more than reshape rivers, they carved deep channels into the human mind and the very structure of our societies. We can see this profound transformation in the archaeological record, where the response to disaster becomes a new blueprint for civilization. Along the Nile, the predictable yet powerful annual flood was the lifeblood of Egypt, but a catastrophic deviation could spell famine. To manage this existential threat, a powerful, centralized state emerged under the pharaohs. This was not merely about building pyramids, it was about survival on a grand scale. The state coordinated the construction of massive irrigation canals and vast grain storage facilities, redistributing food during lean years. It organized labor to reinforce dikes and manage the water's flow. The authority of the god-king was cemented by his perceived ability to intercede with the river itself, turning a potential agent of chaos into a source of political and social order. The flood created the pharaoh. In stark contrast, other communities chose a different path entirely. Archaeological sites in many river valleys show a pattern of settlement and then abandonment, with a thick flood deposit layer marking the clear break. Rather than confront the rising waters again, these societies made a calculated choice to disperse. They abandoned their permanent homes and adopted more nomadic or decentralized lifestyles, moving to higher ground or spreading out across a wider territory to minimize collective risk. This was not a failure but a brilliant adaptation. Their resilience was found in mobility and flexibility, a refusal to be tied to a landscape that had turned against them. The psychological imprint of these events runs even deeper. From Mesopotamia to the Andes, we see the emergence of powerful water deities in art and mythology. These are not just gods of gentle rain, but often capricious, fearsome beings who must be appeased with offerings and rituals. The memory of the deluge was woven into the cultural fabric, a story told to explain a world that could be terrifyingly unpredictable. Ritual burials found in some flood-affected regions show unusual care for the departed, perhaps a community seeking to honor those lost to the waters and ensure their protection in the afterlife. This historical context offers a powerful mirror for our own time. As we face increasing climate disruptions, we are replaying these ancient human dramas. Will our response be greater centralization and large-scale engineering like the pharaohs? Or will it be a turn toward decentralization and local resilience like the dispersed communities of the past? The layers of silt and clay hold more than just geological data. They contain the enduring story of how humanity confronts the unimaginable and the difficult choices between unity and freedom that define our survival. Our own era is now etching its story into the mud. We live in a time many scientists call the Anthropocene, an age defined by humanity's overwhelming impact on the planet, and our flood deposits are beginning to look very different from those of the past. Alongside the usual layers of silt and sand, future geologists will find a new kind of signature, a permanent chemical record of our industrial civilization. In river deltas across the world, like the Rhine, sediment cores drilled today reveal a stark transition. Below a certain depth, you find the natural mineral composition of the Earth. But directly above, in layers dating from around 1950 onward, the sediment is laced with sharp spikes in lead, mercury, and man-made compounds known as PCBs. These are not natural substances, they are the chemical ghosts of our urbanization and industry, washed from our cities and sealed in the mud. Alongside this toxic fingerprint, the very structure of the sediment has changed. The construction of massive dams has trapped the natural flow of coarse sand and gravel upstream, so the flood layers that reach the delta today are composed of much finer grains, a direct and measurable result of human engineering. These modern deposits are more than just a record of pollution, they are a powerful scientific tool. For the first time, geologists have a controlled, observable example of how a specific force, human activity, directly alters the fundamental process of sedimentation. We can watch these layers form in real time, which helps us better interpret the ancient flood deposits from millennia past. We can see how a civilization's choices, from its industry to its water management, get written directly into the earth. This contemporary record also serves as a sobering warning. As our climate changes, the frequency and intensity of major floods are increasing. The catastrophic layers we are creating right now, filled with microplastics and industrial chemicals, will be the stratigraphic legacy we leave for future scientists to uncover. They will study these strata and understand that a global civilization, armed with unprecedented knowledge, saw the patterns of the past and yet continued to build on vulnerable coasts and pollute its own waterways. Examining these modern analogues forces a profound reflection. We are not outside the historical cycle we have been exploring, we are part of it. We are another civilization facing water-related cataclysms, our choices now being recorded in the very ground beneath us. This realization is not meant to paralyze but to empower. It urges proactive measures, reminding us that the knowledge we have gained from ancient mud and forgotten floods provides us with something our ancestors never had, a clear guide for how to build a more resilient future before the next layer is sealed in place. The science of ancient floods is more than a study of mud and stone. It is a dialogue with the past that carries profound ethical weight. Unearthing these cataclysmic layers often means working on lands that are sacred to indigenous communities, places where the memory of displacement is still part of a living oral tradition. The act of extracting a sediment core is not neutral. It can be seen as a violation if done without permission and deep respect. Modern researchers are increasingly guided by a principle of collaboration, entering into partnerships with tribal nations and local communities from the very start of a project. This ensures that knowledge is gathered with consent and shared in a way that honors cultural heritage, transforming a simple geological survey into a joint effort to understand a shared history. This collaborative spirit extends to how findings are communicated to the public. The story of a past cataclysm is inherently dramatic, but sensationalizing the human suffering it caused crosses an ethical line. There is a crucial distinction between conveying the immense power of a natural event and exploiting the trauma of those who endured it. Responsible science requires presenting these discoveries with nuance, highlighting what we know while clearly acknowledging the gaps in our understanding. When connecting ancient flood deposits to modern climate risks, the emphasis must remain on evidence-based projections. The goal is to foster a clear-eyed understanding of vulnerability while also highlighting the incredible resilience that human communities have demonstrated time and again. This balanced approach builds public trust and empowers people with knowledge rather than paralyzing them with fear. Ultimately, the ethical framework surrounding this field ensures that our quest to understand the Earth's turbulent past strengthens our present-day society. It sets a standard where geological discovery and cultural sensitivity are intertwined, reminding us that the most important layer we can uncover is not in the sediment, but in the respectful relationship we build with the people connected to it. These silent layers of mud and stone cannot speak for themselves, yet their stories echo across multiple fields of science. Reconstructing a forgotten cataclysm is like assembling a vast, fragmented puzzle where the pieces are held by different disciplines. A geologist examines the coarse texture of a sediment layer. An archaeologist finds a collapsed wall in that same stratum, and a climatologist identifies a period of extreme rainfall in an ice core from another continent. Only when these disparate pieces are brought together does the full picture of the past begin to emerge with stunning clarity. This interdisciplinary approach transforms scattered data into a coherent narrative. For instance, the mighty Nile's ancient floods were long a mystery recorded only in fragmented hieroglyphs. By combining sediment cores from the delta, which show distinct bands of silt, with isotopic analysis of those sediments, researchers can determine the intensity and source of each inundation. When this geological timeline is then placed alongside the precise chronologies of Egyptian dynasties from historical texts, a powerful pattern emerges. Periods of stable, predictable flooding align perfectly with eras of pyramid building and territorial expansion, while layers of chaotic, destructive sediment correspond with recorded famines, social unrest, and the collapse of central authority. The river's behavior, written in the mud, directly shaped the fate of pharaohs. The same collaborative spirit is revolutionizing our understanding of human migration. Geneticists tracing the journey of modern humans out of Africa through DNA have identified major population bottlenecks and dispersal events. When these genetic timelines are overlaid with maps of ancient flood deposits and dried lake beds, the correlation is striking. It appears that periods of catastrophic drought in the Sahara and flooding in the Nile Valley acted as powerful pumps, pushing groups of early humans out of familiar territories and into new continents. The cataclysm was not just an event, it was an engine of dispersal, its force recorded in both our genes and the soil. This synergy between fields allows us to move beyond simplistic cause and effect. We see that a single flood did not just destroy a city, it altered trade routes, shifted political power, and forced technological innovation in water management. By embracing this holistic view, we do more than solve historical mysteries. We develop a sophisticated blueprint for understanding modern environmental challenges. The collaborative decoding of Earth's cataclysmic past is, in fact, our most powerful tool for navigating an uncertain future. The ground is yielding new secrets through the eyes of machines. Artificial intelligence and machine learning are now sifting through mountains of sediment data, detecting patterns invisible to the human researcher. These algorithms can scan countless sediment cores, correlating the thickness of a flood layer in an Asian lake with a specific shift in an ice core from Greenland. They are connecting dots across continents, revealing a synchronized pulse of global flooding events that we never knew existed. It is like discovering a hidden rhythm in the Earth's own heartbeat, a pattern of cataclysms that swept the planet in unison. Meanwhile, ambitious deep-sea drilling projects are pushing further back in time. The ocean floor is the ultimate sedimentary archive, preserving a near-continuous record of everything that has washed off the continents. New missions aim to drill into older, deeper layers, potentially recovering evidence of Pleistocene megafloods or even more ancient deluges that reshaped the world long before humans walked it. As our physical reach extends into the seabed, our temporal precision is also sharpening. Advanced dating techniques are achieving resolutions of decades instead of centuries. This newfound clarity has the power to settle long-standing debates, perhaps finally determining the exact sequence of events that caused the Mediterranean to refill or providing definitive evidence for the Younger Dryas impact hypothesis. Each technological leap promises a more complete and likely more turbulent picture of our planet's past. This is not the end of the story, but a new beginning. The quest to understand ancient floods is accelerating, driven by tools that allow us to see further and with greater clarity than ever before. It is an open invitation for the next generation of explorers to join this dynamic search, to read the next chapter in the Earth's deep time diary. The science of forgotten floods is no longer confined to laboratories and academic papers. It is spilling out into our communities, inviting everyone to become a detective of the deep past. Citizen science projects are now empowering local volunteers to contribute directly to this grand investigation. After a major storm, you might find people walking riverbanks, carefully photographing and mapping freshly exposed layers of sediment. These newly revealed cliffs and cuts are temporary windows into the Earth's history, and volunteers help document them before erosion washes the evidence away. Others collect bagged samples of mud and sand from agreed-upon locations, their careful labels and precise GPS coordinates adding thousands of data points to regional paleoflood databases. This crowdsourced effort allows researchers to monitor changes across a vast area simultaneously, a task impossible for any small team of scientists. The raw data gathered by public hands is helping to fill critical gaps in our understanding of how often cataclysms have visited particular valleys and coastlines. Beyond fieldwork, educational programs are bringing these concepts to life. In museums and school classrooms, interactive stream table models let students create their own miniature landscapes. They watch as flowing water carves channels and then drops its sediment load, building visible layers that tell a story of drought and deluge. By physically participating in the process, complex ideas about stratigraphy and deposition become intuitive and memorable. This hands-on learning demystifies geology, transforming it from a distant science into a tangible exploration of our own backyards. This collaborative movement does more than just generate more information. it builds a profound connection between people and the ground they live on. When a community helps uncover evidence of a 1,000-year flood that once reshaped their local river, that history ceases to be an abstract concept. It becomes a part of their shared environmental heritage, fostering a powerful sense of stewardship and a deeper understanding of the land's dynamic nature. This participatory approach truly democratizes discovery, proving that you do not need a doctorate to help uncover the cataclysms absent from our history books. The silent layers of mud and stone are not just for specialists to interpret, they are stories waiting for any curious person to help read. Each of us can pick up a trowel, examine a roadside cut, or simply learn to see the landscape with new eyes, contributing to the next chapter in this unfolding story of our planet's turbulent past. These layers of mud and stone are our planet's oldest historians, narrating a past written in water and resilience. Our journey through these silent archives has revealed a history far more dramatic than any book could contain, a story of continents reshaped and civilizations tested by forces beyond their control. From the Mediterranean's violent rush into the Black Sea to the titanic currents that carved the American Scablands, these deposits challenge the very notion of a stable, predictable past. They force us to see human history not as a steady march of progress, but as a series of profound adaptations to environmental chaos. This understanding is the ultimate legacy of the flood deposits. It is a story woven together from the threads of geology, archaeology, climatology, and the enduring power of human memory preserved in myth. This interdisciplinary tapestry shows us that the goal is not merely to date a disaster, but to comprehend the full scope of its impact, from the migration of peoples to the birth of new gods and the restructuring of societies. The ethical care taken in this work ensures we honor the communities connected to these lands, turning scientific inquiry into a shared exploration of our collective heritage. The philosopher George Santayana's warning that those who cannot remember the past are condemned to repeat it resonates with profound urgency today. As our climate changes, the lessons sealed within these ancient layers become more critical than ever. They remind us of our planet's immense power, and just as importantly, of our own human capacity for ingenuity and adaptation in the face of the unimaginable. We are now the authors of the next layer, and the choices we make will one day be part of this same geological record. What story will we leave for the future to uncover? If these mysteries of the deep past have captivated you, share your thoughts in the comments below. Subscribe to continue exploring history's hidden chapters with us, and join a community dedicated to preserving the incredible stories written in the very ground beneath our feet.